We are the paradoxical ape. Bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves. Aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. CARTA brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
Today I'll be talking about a framework I've developed called Intersectional Neuroscience, which adapts research methods to fit as many diverse people and brain structure as possible. And I did this within the context of studying the neuroscience of meditation. So meditation exercises are ancient Buddhist practices that are increasingly used to cultivate health in the general public. In 2017, around 14% of US adults were practicing meditation, which is about 35 million people, and it's only growing since then. Meditation practices have been adapted to treat mental and physical health conditions such as stress, depression, anxiety, pain, and cancer. And overall, we see moderate improvements. This is somewhat counter to what you may see in the press, where meditation may be treated as a cure-all or a really strong intervention. And this is because different people actually respond to meditation in different ways. It's not a one-size-fits all. So how do we understand these processes to help maximize results for each person? In mindfulness and meditation practices, people are training multifaceted components of attention, including the object of focus, meta-awareness or being aware of one's own mental states, being present-centered, and also emotional components such as being non-judgmental and compassionate. So as you can see, there are many different types of attention being trained. So in the popular press with meditation and the brain, there's a certain cultural conditioning around how we're understanding the results. The main message is meditation changes the brain, which is super exciting, very motivating. And you'll see these headlines and story covers. And the cultural conditioning in the media is that meditation and brains are monolithic and universally change in more or less the same way. So you'll see things like meditation changes brain structure in this area in the insula, which is involved in body awareness and emotions. Or meditation increases brain activity involved in cognitive control, and you may see regions change in the prefrontal cortex. Meditation reduces pain perception. And the brain can be trained to become more compassionate. And this is from my own dissertation work from the Center for Healthy Minds at the University of Wisconsin-Madison, where he found that people became more generous after practicing compassion meditation for just 2 weeks, when they envisioned the suffering of themselves and other people, and then practiced feeling kind and wanting to help those people. And we saw that as people became more generous from the compassion meditation, they also increased activity in the inferior parietal cortex when viewing pictures of people suffering. And so this result was really exciting. We do have this meditation freely to download, and over 31,000 people around the world have downloaded it and practiced, and that makes me feel really good that seeds of compassion are being planted around the world. However, what may be less obvious is that this region came out from an average of 41 different brains. And when I was a graduate student doing these analyses, what I saw is that averaging brains together actually wiped out most of the results. Yet if you looked at each person individually, there were clearly things going on within each individual brain. Scientists also do meta-analyses, or finding the average of the averages from other studies, and we do learn very interesting things. So for focused attention to the breath, we see increases in the insula involved in body awareness and decreases in the posterior cingulate cortex, which is involved in the default mode network. And that's activated kind of when we're left to our own devices, when we're mind wandering, when we're thinking about our lives, when we're daydreaming. And so those areas get dampened when we learn to focus on the breath. And so these results start to feel very concrete and real. And again, we get this message: meditation makes you happier and improves your brain. And these are really tempting, simple stories. I myself want to believe them and have believed them in the past. And there's this underlying message that meditation universally changes the brain, in quotes, because if you think about it, there's no one average brain that exists in the world. Rather, there are many diverse billions of brains. And so people in the audience, you might have tried meditating. How many people have found it to be this magical cure that instantly improves all areas of your life? I think that happens to very few people. Rather, you start to experience subtle shifts in different areas of your awareness, which may or may not start to change areas of parts of your life. And so as a clinical psychologist and a researcher and a meditation practitioner, what I found is that people's responses to meditation are quite diverse, and that we can adjust the way we teach practices. We can understand the context of the person practicing to adapt practices to fit their lives, and people seem to get improve in their health more quickly when I was able to adjust individually to them. And this is just a reminder that people and their brains exist within complex social ecological environments. There's tons of literature on this. You can look up Bronfenbrenner's ecological systems theory. So there's the individual person, and then there's our context of school, family, neighborhood, medical systems, and then there are larger systems, legal services, communities, and then the macro system of the geopolitical environment. And so going back to this average brain approach, you can see two individual brains here. You can see that they have different brain structure, yet in most studies, we average them to fit a standard brain. And then we get new pictures that look more like the standard brain, and then we average them together. And the underlying assumption to this approach is that brain activity works similarly across different people, when in reality, people differ in their brain structure and function, and everyone's minds work differently. So as a scientist, my goal is to more accurately capture reality, measure things better so we can learn things to help people. And so I worked on this paradigm shift to treat brain activity as unique, like fingerprints. So the same technology used to recognize faces and fingerprints can be applied to brain data for pattern recognition or machine learning. And this was developed by Jim Haxby and colleagues almost 20 years ago. And so I've adapted these methods to apply them to studying meditation. And this really involved a process of integrating multiple experiences of personally meditating, my scientific experiences where I saw the averages weren't working so well, and my clinical experiences where people in the room are quite different, and you have to adjust to them to help with their mental health. And so I had to sit with all this, and I came up with a new framework, which I call intersectional neuroscience, to actually fit and accommodate people's diversity rather than try to take it away with averages. And so the established way of studying the neuroscience of meditation, which we call contemplative neuroscience, typically it's been studied by weird populations or Western educated, industrial, rich, and democratic. The evolving ways that they're increasingly diverse scholars, more international as well. And who we study in the United States has typically been depicted as individual people in power. And so we are now going to also study underrepresented people who practice in community at the East Bay Meditation Center. How we study is that scientists typically have almost all of the power in setting the questions, developing the methods, running the studies, analyzing the data, writing the publications, and then communicating it back to the public. And so there are community engagement methods where you can involve the communities you study at each level of the scientific process. And in the neuroscience methods, instead of average brains, we're going to take a more individualized approach using machine learning. So we collaborated with the East Bay Meditation Center, and we use community engagement methods, and we also use these individualized neuroscience methods. We did a literature review, including of that large meta-analysis I just showed, and our literature review showed that there's an overrepresentation of white participants in the United States and an underrepresentation of Black, American Indian, and Native Hawaiian or Pacific Islanders, as well as mixed race people and Hispanic people. And this is not specific to meditation studies. This is a wider issue in academia, in science, and in neuroscience. So we collaborated with the East Bay Meditation Center to increase the diversity of participants, and their mission is to foster liberation, personal and interpersonal healing, social action, and inclusive community building. And it's one of the most diverse Buddhist communities in the United States. So they have specific meditation groups or sanghas for different marginalized groups, including people of color, and the Alphabet Sangha for LGBTQ plus people. There's the Every Body and Every Mind Sangha for people with disabilities and chronic health conditions. There's People of Color Yoga. And the reason why these groups separate out is to form a sense of safety and community where they can practice. And at the same time, they're also cultivating a multicultural community so that when people from different groups come together, that they can build a culture of communication that's more equitable and respectful. And so a few important ones to try on different perspectives, to know there's a difference between what you intend to say and how it impacts other people, and moving up and moving back. So if you're used to speaking up a lot because you may belong to more privileged groups, you may learn to take a step back. If you belong to more marginalized groups, you may practice stepping up. They have different classes, such as for teens, for white people to process issues of privilege, practicing with strong emotions. They have long-term programs, right? Because cultivating new ways of being with each other and self-understanding takes time, right? So they have year-long courses for social justice activists, for white people, and for integrating meditation into daily life. They have many talks and website resources. Lots of their programs have been switched to Zoom online, so please check out their website at eastbaymeditation.org. So our community engagement approach uses community-based participatory research, which aims to enhance the well-being of underserved populations through cultivating ethical, respectful, and responsible relationships with participants and the community. And so community stakeholder and academic perspectives are engaged throughout the research process. And it's an embodied process, which I really love about it. You have to practice cultural humility. You have to include people at every step, from design to publication. You need continuous dialogue and communication. You need clarity over time and compensation, including building in compensation and grants. And if you compare this with interacting with people with more privilege, this should be obvious and automatic. Of course, if you're working with your hero, you would display humility and include them at every step. But if you're working with people that have less social privilege, you tend to take those things for granted. And so you really have to practice continuously. And this is to show a way you can display cultural humility, although you have to practice it throughout. And this is an example from an email where I explicitly acknowledged previous inequities and harm from the academic and scientific communities, and that I was open to any dialogue and feedback if this harm was repeating itself, and that I was willing to change my behavior. And this shows a way to actually equalize the power dynamic. We were able to embody principles of social justice through community engagement and sharing resources with EBMC. So first we engaged key community members, Xiaojing Wang and Musha Makita, who helped us form a focus group to develop culturally sensitive procedures for racial and ethnic minorities, LGBTQ people, people with disabilities and chronic illness, the fat community, and people with lower income. We held community events at EBMC where we could get even more feedback from the community, and we developed ethical consent processes for sharing demographic and brain data. And we also shared credit and resources. So this came in the form of payment, co-authorship, and attention. So when I give talks, I always highlight the culture at the East Bay Meditation Center. And so this was really exciting for me because I could find a way to do research as a form of embodied social action. So when people ask, what can I do in terms of social justice issues, I say start where you have some more privilege and power and influence. And for me, that was my research world. And so cultural adaptations included making the study more person-centered and inclusive. So we really took the perspective of these different people with the focus group and reframed the study to think of who can safely be in the brain scanner, who can pay attention to their breath, and be more inclusive of people with neural diversity. And so we made a flyer that was more person-centered, and people could self-select in or out before communicating with us, and then we could screen them. And so this is a list of all of our cultural adaptations. It's listed in a paper that I'll show later. Some of my favorite adaptations that we did was changing our demographics form by honoring lived experiences and how people self-identify, as well as measuring in standard scientific language and classification. So for race, we first asked, with which race or races do you identify? And people could fill it in. Then we asked, for the purpose of scientific reporting, with which races do you identify? And then it lists the NIH categories. Same thing for gender. How do you self-identify your gender? And people could type in and self-identify. And then we say some reviewers may ask for more general categories. So with which category do you choose to identify your gender? And this just recognizes that people's identities don't fit in these neat little boxes, that there's really a variety of experiences, and we allow space for both to exist. Okay, and I was able to show His Holiness the Dalai Lama the East Bay culture in 2016 in Mongolia, and he was very interested in how they were developing a multicultural community. And so by using community engagement, we were successful in recruiting 80% racial and ethnic minorities and 53% LGBTQ people. This included members of the Black community and Indigenous communities. However, we need to improve in including people with disabilities and people with lower education and income. So next, we honored neural diversity using individualized neuroscience methods. And so we have a measurement issue in meditation because mental states are internal, diverse, and fluctuating. So when you focus on your breath, you may start there, but as we know, other things start to happen. You think about dinner, you get sleepy, you think about world peace and public health. And again, averaging everything together is the way most people do it, yet it may not make the most sense given the diversity in mental states. And so we now apply multivariate machine learning approaches which are individualized. So how do we do that? So we need to add brain data where the computers can learn what these internal mental states look like for each person. So we train a machine learning classifier to learn what different states of attention looks like, including the breath, mind wandering, and self-referential processing or thinking about your life. We could then apply these brain patterns to assess what's happening in a 10-minute period of meditation. So it can classify whether people are on their breath, mind wandering, engaging in self-referential processing, and then we can quantify these metrics into new metrics such as what is the percentage time you were focused on your breath? Because when people start to meditate, we actually don't know what's happening with their attention moment by moment. So this study and method is one of the first measures that can objectively assess that. So again, we explicitly instruct people to pay attention to their breath, to stop paying attention, which induces mind wandering, to think about the past week, the next week, and right now, to induce self-referential processing, and control conditions of paying attention to their feet to get a more accurate picture of when they're on their breath, and also to pay attention to the sounds because the brain scanner is actually very loud. And we just direct their attention every 16 to 50 seconds so the computer is slowly collecting information on what their brain patterns look like. And so our first question is, can machine learning differentiate between these 5 internal attention states? And even though people's eyes are closed the entire time and the only thing changing is their internal focus of attention, the brain scanner can indeed pick up the individualized brain pattern for each mental state. And it worked for all 8 meditators. We studied all 15 East Bay meditators, and it worked for 6 out of 8 controls, or 75%. This slide highlights the neural diversity. We found the voxels, or little 3D pixels in the brain that maximally differentiated between breath, mind wandering, and self-referential processing. And you can see each person has a different brain pattern for each mental state, as well as across different people. They have quite different brain patterns. Blue means there's less activity, orange means there's more activity, and you can see even across people, their brain signals for focusing on the breath or mind wandering are quite different. And so the real power of this is now we can use this information to decode or estimate what people may be focusing on during meditation. So the computer learns the brain patterns, and then for each brain pattern during the meditation period, it asks, does this look more like breath, more like mind wandering, or more like self-referential processing, and makes a decision. This is like when classifiers make decisions about whose face they're seeing or which fingerprint they're seeing. And so we get these individualized readouts of mental states during meditation. For meditator 1, you can see when they're on their breath, when they're mind wandering, when they're self-referential processing, they come back to the breath, they mind wander, they think about their lives, they come back to the breath, etc. And so this approach gives us data that looks more close to what we know we experience during meditation, which is a fluctuation of mental states. And so for meditator 2, they have a different set of fluctuations for when they're on their breath, mind wandering, or self-referential processing. This also works in control participants. So we can study novices who learn meditation to help their health. We can quantify breath events, mind wandering events, and self events. We can count how many times they were on their breath and quantify their percentage time on the breath, how many times they were on the breath, and how long, the duration. And then we can create these individualized attention profiles during meditation for each person. You can see meditator 2 spent more time on their breath versus mind wandering or self-referential processing. But for meditator 3, they actually spent more time thinking about their lives than they were on their breath. And that's actually also quite common during meditation. And then we can initially start to look at the data from a group level. We show here that on average, people are spending more time focusing on the breath compared to mind wandering or self-referential processing, and this is due to a longer duration on the breath. So overall, it seems like people are able to engage more with the breath when they're meditating on the breath, and that's also encouraging, but we need more data and types of experiments to really tease this out. To learn more, you can read the 2 published papers. This one goes into the embodied task in more detail, all the machine learning technical components, and this paper, Toward a Compassionate Intersectional Neuroscience, describes the entire intersectional neuroscience framework. And our main conclusions really are is that we can change all of our research methods to be more inclusive of marginalized groups using an intersectional lens. We can use community engagement and individualized neuroscience methods which honor neural diversity, and then we can create individualized metrics based on that neural diversity. And so what I didn't mention before is that neuroscience is actually quite exclusive. We exclude left-handers, we exclude people with mental health disorders, with neurological disorders. And as we know, for health interventions and meditation, people come to meditation because they're experiencing some sort of distress, and so we should really include them in our studies. The framework's iterative. You continually need to adjust to the people in your studies, and cultures constantly change. And I hope this study shows that there's no one brain in meditation or any other psychological process. There are many brains and experiences. And that our scientific methods and discoveries will improve by including more diverse perspectives in our participants, our students, and our scientists, and that embodying intersectional approaches in your research is possible, and it is a transformative process that you yourself change as a person as you learn to be more inclusive and to practice cultural humility. All right, and overall, meditation helps us to slow down our mental processes, bring awareness, bring kindness to our experiences and to other people, so that we may develop the mental space to choose a better way of interacting, to change negative cycles, and to cultivate healthy habits. And so my question for people in the audience is, what cycles will you try to change if you have a meditation practice or some other mind-body practice? And thanks to all my mentors and collaborators at UCSF. Neuroscape, the UCSF Osher Center, the East Bay Meditation Center, and to all our funders. And I'll stop there.